Assalamu alaikum. My name is Sarar Khan, and today we will talk about programming, Solidity programming. The main thing is to create an environmental setup. For Solidity programming, we can access Remix online. You don't need to install anything. If you want to use it without connection to the internet, you can use this GitHub link. Actually, this is an open source web and desktop application, and it is a fast development cycle which has a rich set of plugins with initiatives GUIs, and it is written in JavaScript and supports both usage in the browser in the and but run locally and in the desktop version. It has modules for testing, debugging, deploying of smart contracts. And next is basic syntax. In the Solidity programming, we use the pragma in the start. Pragma is the first line, that is a directive which tells us that the source code is written for Solidity version or anything new. This directive is always local to a source file, and if you import another file, the pragma from that file will not automatically apply to the importing file. So it can be written as this pragma Solidity, this sign 0.6.0. I have used this version. Then after that, we will be using this contract counter. What is this contract? Is a collection of code, its functions and its data that resides at a specific address. That specific address is on the Ethereum blockchain, and this is used for smart contract. Actually, name of the smart contract is this counter. And the next we have uint count. This uint is basically value for this count is a value for counter. It is a variable, and then it is followed by semicolon. This uint is a type of count because it will contain number in it, and this uint is unsigned integer. It can't be negative. Minus sign will not be available in this uint, and we can increment this. Next we have this function get this constructor. Constructor is used for initializing the variable, and we have initialized this variable with the constructor that is being public in the beginning. And this constructor is basically looks different. How? Because it run only once. When smart contract deployed, set the count value explicitly, starting with the 0. Then we have this function get count. This function is a way to reusable code inside the smart contracts and perform some sort of operations. This get count, this read the count from this variable and then return it back to us. And then this is the returns count, special key which is used for returning with the values. And the thing is how to make this function assemble, assorted. This public is used for visibility of a function. What is the purpose of this view in the function? This view is used for how to specify type, view value of the count of the data. We say we return count. Here we are informing that we are returning the count. And what does this return is useful? Return because we said it is uint. We are telling that this is uint and then returning this count. This count is a special type of variable. This is a state variable. Count value gets stored to the blockchain and then specify what it returns. This is an increment function. This is an update function. And now for deploying this code, first of all, we will compile this. I will compile this basic syntax and we have to check this compiler in the start. I am using 0.6.0, so here it should be 0.6.0. And I am compiling this basic syntax. It is compiled and now we have to check the environment, which is JavaScript VM. Then after that we have to check this, we have to click on this deploy. Yes, here you go. Increment count and get count, these are the two functions. Get count, that is 0. I am incrementing it, then get count, it is getting plus 1. Increment count plus 2. So this function is working properly. Okay, this is another syntax, basic syntax. In the beginning, as I have told you, pragma solidity is being used, and this directive is always local to a source file. And for a file which will not compile earlier than this, we'll be using different versions. Then this contract, which is a collection of core and a data. This basic syntax is the name of my contract. And this uint is an unsigned integer with the stored variable in which the data is being stored. Now this is my first smart contract. In this I have used the same version, Pragma Solidity, and the contract, which is a collection of code. This first smart contract is the name of my smart contract, and this is a constructor. Then the function get result. It returns arbitrary value inside the smart contract, and it returns the value of a basic local variable. This uint is a type of integer, this value is a variable, and this 6 is storing the numbers. This 6 is being stored in this variable, and at the end it is returning the result of adding these two variables. So this is a simple basic smart contract. I'll be compiling this by checking the compiler, then compiling it, and now I'll be deploying this. Deployed. Now this is my first smart contract. This is the get result function. The 6 and 3, this is being added here, and now the result is 9. So it is also working perfectly. Solidity support both C style and C++ style comments. Here the pragma solidity is being used. Any text between these two lines, this is a comment, it is a similar to comments in C++. And such type of comments, this is a multi-line comment in Solidity. It is very simple. So in the case of types, writing a program in any language, we need various variables to store the various information. Variables are nothing but reserved memory location to store values. This means that when you create a variable, you reserve some space in the memory. And we need value types for this. Solidity offers the programmer a rich assortment of built-in as well as user-defined data types. There are different data types: Boolean, integer with int 8 into 56, uint 8, u into 56. Fixed point numbers. And next thing is, here in this program, it is being shown the string public my string hello world. So the type string is also being declared here. Next, int public my int is equal to 1. It is having a value of 1. Uint public my uint. This my uint and my uint to 56. U into 56. There are different sizes of this uint 8. How big actual number can be optimized in a smart contract? In this uint, we cannot have positive or negative sign. And this uint 256 and simple uint, they are both are same. This uint 256 is a default. So my topic is variables. There are variant type of variables. This is a state variable whose values are permanently stored in the contract storage. This value stored data is equal to 38. This is permanently stored. And this constructor is being used. Variable scope is being used. Scope of the variable is limited to function in which they are defined, but the state variables can have three different type of scopes: public, internal, and private. Private state variables can be accessed only internally from the current contract, and internal state variables can be accessed only internally from the current contract or contract deriving from it without using it. And the public state variables can be accessed internally as well as via messages, and it is easily visible. Logical operators. Solidity supports some logical operators, that is logical and, logical or, logical not. Here the same function is being used, contract of the logical operator is being used, and at the here it is this function get result is returning function integer to string. The result of that integer to string is being returned in this function. And after that the function is function integer to string. Here we are using equal to operator, and after that with a while loop we are using logical not. Reverses the logical state of the operand. If the condition is true, then the logical not operator will make it false and return the result in get result, returning integer to string result, accessing the state variable. Solidity supports some arithmetic operations, that is addition, subtraction, multiplication, division, modulus, increment, and decrement. So here we are using an addition operator. It works for numeric as well as strings in the double quotes as well. How to use arithmetic operators are being shown here. These are the two variables, they are being added here and then returning the result in an arithmetic operation. There are variant loops. The for loop is the most compact form of looping. We can have different parts in it: loop initialization, test statement, and iteration statement. In the loop initialization, where we initialize our counter to a starting value, and this statement is executed before the loop begins. This whole program is being shown by declaring the value of a local variable at the end and using the for loop example. Here the for loop is being used for initialization. The test condition iteration statement is being used and statement to be executed in the body of it. It contains three steps. It is giving us the condition. If that condition is false, it will get terminate for the condition. If it is true, conditional code can be reversed again. The most basic loop in Solidity is the while loop, which could be discussed here. The purpose of a while loop is to execute a statement or the code block repeatedly as long as an expression is true. Once the expression becomes false, the loop terminates. So we are checking the while loop over here by declaring the comparison, the equal operator, not equal to operators. Here the while loop is being used, and after that bytes memory is also being used for declaring the length of these variables. Here in this program we'll be talking about arrays. It's a data structure which stores a fixed size sequential collection of elements. And in Solidity, an array can be of compile time, fixed size, or of dynamic size. Here in the beginning we'll be giving the contract and of the named arrays. This is a single dimensional array. The array size must be of integer and constant greater than 0, and type can be any valid solidity data type. Here uint length is equal to 7. So I am declaring the array called this length of type uint. To declare an array of dynamic size in Solidity, the programmer specifies the type of the element. So here the bytes is also being used and uint is also being used. In the Solidity, the string literals are being used using the double quote and a single quote. Here the contract of working of a string is being used, same function, unsigned integer with two variables and giving the result an integer to string. This function is the second function is being used, integer to string. Uint slash I. What does this slash I means? It is used for byte string passed in, and it can be used with the push function as well. Essentially, just take these values, and after that, it is returning the memory with an internal variables. And next, it is using the operators, equal operator, not equal to, and to use it is being used for the bytes types instead of string, as string operation requires more gas as compared to the byte operation. Bytes can be converted to string using the string constructor. Bytes memory bstr is also can be used here. Special variable means dynamically scope variable. It means that special variable can acquire a value on entry into a lexical scope. And when that lexical scope terminates, the previous value of that variable is restored. And these special variables are globally available variables. Provides information about the blockchain. So these are the special variables mapping the address, and these balances are visible by declaring the new balance, and these are providing the information about the blockchain. How it can be compiled? It can be compiled from here by checking up the compiler. Now the next task is deploying it. Question arises, why do we use functions? We use function for reusable code, which can be called anywhere in your program. And it eliminates the need of writing the same code again and again, and it increases the efficiency. It allows the programmer to divide a big program into a number of small and manageable functions. Before we use a function, we need to define it. The most common way to define a function is by using the function keyword, as it is clearly mentioned here by declaring the function of getResult. It will give us the output, so we can call a function, we can get the result out of the function, we can do further. These are the view functions. They ensure that they will not modify the state, and on the other hand, pure functions, they do not read or modify the state. They can be declared as view by, compiler will throw a warning in some cases, modifying the state variables, emitting events, sending ether via calls, using low level calls. And on the a pure function, what's the purpose of this function? They do not read or modify the state. It can be declared as pure. And compiler will throw a warning in such cases, reading state variables, calling any function not marked pure, using inline assembly that contains certain opcodes, and addressing balance in such cases. Pure functions can use the revert and require function to revert potential state changes if an error occurs. And here the values are being given 50 and 99. So with the product A cross B and A plus B, it will return the result Solidity provides a few inbuilt functions for performing mathematical and cryptographic operations. They can be used for a variety of tasks, including hash calculation and public key retrieval. So there are numerous functions that are being used for KECCAK 256, SHA-256, X-ray cover 256 that returns address. One of the function is being used here, and it is calling this function with the public pure and returns bytes 32 result. As it is clearly mentioned that this function returns bytes 32 in the result, and the input is being given A, B, C. So after compiling this, libraries are similar to contracts but are mainly intended for reuse. A library contains functions which other contracts can call, and the characteristics are like a library cannot be destroyed as it is assumed to be stateless. A library cannot have state variables. A library cannot inherit any element. So in this case, we'll be using library instead of contract. Function index of for storage, and this public view in which we will be viewing the value of this uint integer. Then the contract library is also being used with the push function. So this is error handling. Actually, Solidity provides various functions for error handling, and there are some of the important methods used in it, like bool condition, assert, bool condition require, bool condition with the memory, revert, and revert memory reason. The bool condition in which in method calls causes an invalid opcode and changes done to the state got revert. The next is bool condition of require in which the condition is not met. This method call reverts to the original state. So here for the error handling, we'll be trying to understand the code how error handling works in Solidity. When revert it is called, it will return the hexadecimal data as followed.